Okay, so here is lesson 5.02, just a very brief recording to help you guys out as you do the problem set. Notice that the problem set is here. It's problems 11 through 29 odd on page 429. So basically, when you look in your textbook, it's just continuing through that same kind of lesson, although this goes into a little bit more depth, a little bit more complexity. Okay, so here we go. All right, here's an example, kind of similar to what I talked about in class. A baby is putting cube-shaped blocks in a cube-shaped box. Each block is 1 inch on a side and the box is 1 foot on a side. How many blocks can the baby fit in the box? So one thing that you want to think about here, and it might help to draw a picture. I'm going to insert a picture here to help me think about this. Normally I would draw it by hand, but because of the way that PowerPoint works, I can't. So if I were to draw myself a big box and think about the fact that this right here, let me see if I can get my pointer here, that this side right here, right, is supposed to be 1 foot. If this side is 1 foot, that's the same thing as 12 inches, right? So, because the reason why I'm interested in inches is it says that each block is 1 inch on a side, so I don't care that this is 1 foot. I want to know that this is 12 inches. So if this is 12 inches on a side, then I know that every side is 12 inches. Because there are 12 inches in a foot, again. So then I want to know how many blocks can the baby fit in the box. So if it's 12 inches on a side, then I'm going to use that volume formula again. That volume is the side cubed. So I'm going to be looking and saying, well, 12 inches on a side, so I need to cube 12 inches, which is going to be quite large. You know, this is 12 times 12 times 12, which is 144 times 12, which is, and I'm going to use my calculator now, 1,728. Wow, that's really huge. And then just like we talked about before, we do, whoops, don't want it caps locks. We do, sorry, we do want to put our units on there. So how many blocks can the baby fit in the box? The baby can fit 1,728 blocks in the box. Oops, that's still an exponent form. So it would be that number of blocks because that's how many inches cubed are in the box. And each of the baby's cube-shaped blocks is 1 cubic inch. There are 1,728 cubic inches. So therefore 1,728 blocks. So what this lesson is largely about is like changing between units, and also a little bit about talking about capacity and volume. Capacity is kind of the same thing as volume. It's kind of one of those things where you use different words in different situations, but they're essentially the same thing. So when you think capacity, think volume. Capacity is how much something holds. It's, like I said, basically the same thing as volume. It's just a different way of saying it. So we would say, what's the capacity of this glass? Essentially the same thing as volume. Capacity of a container with what we're doing in this lesson is often going to be stated in liters or milliliters. Similar to, like, you could say, well, how much is the capacity of this glass? You might say it's an 8-ounce glass. Ounces are the standard measurement of volume or capacity, but we are transitioning much more to the metric system, which would be liters or milliliters instead. And if you guys take a look at, maybe if you have a measuring cup in your house, in your kitchen, a proper measuring cup, not the kind that, you know, doesn't have measurement marks on it, but like one that you can pour things out of, you'll often see that it'll have ounce measurements, but sometimes it'll also have milliliter measurements. Or it'll say something like, here's a third of a cup, here's a quarter of a cup, here's half a cup, 3/4 of a cup, here's a cup. And then you'll also see where it'll also give you, you know, this is 1 ounce, 2 ounce, 3 ounces. Sometimes they'll also have the milliliters on there. They'll say here's X number of milliliters, you know, 8 milliliters, 10 milliliters, that kind of thing. So take a look at that. You'll also notice it on like cough syrup. You know, like when you have the little measuring cups that'll come with cough syrup or other kind of liquid medicine. If you have younger brothers and sisters, you probably still have some of those in your house, or even if you, like I said, have cough syrup or something like that. Those little things will often have milliliters on them also. So take a look. If you haven't noticed it before, do that. You'll also notice that like your gallon of milk will often give a measurement in liters as well. So You'll also hear the term displacement. Displacement is really also the same thing as capacity or volume. Displacement generally refers to how much water you would displace if you were to submerge the object. So I don't know if any of you have ever colored Easter eggs, but if you have, then you have experience with displacement, because if you put the egg into the dye, you'll notice that the level of the water goes up when you put the egg in. That change in the level of the water, that is displacement that you're seeing. The egg displaces the water. It makes the water have to move out of its way. So you can find the volume or capacity of irregular objects, things that aren't easy to measure, like an egg, because they're round, and so that's kind of a difficult situation. You can find the displacement of an object, and that will actually tell you its capacity or its volume. So hopefully that helps with the vocabulary that you're going to see. This is important to know right here. 1,000 milliliters equals 1 liter. Milli literally means thousandths. Okay, so anytime you see milli something, like millimeters, that means 1,000ths of meters. So milliliters means 1,000th of a liter. So milliliter is not very big. I'm going to talk more about that in a second, or right here. Okay, so another rule here is that 1 milliliter is the same thing as 1 cubic centimeter. This is why liters are metric based and not standard or English system. So it's 1 milliliter is the same as 1 cubic centimeter. Sometimes we say 1 cc. cc actually stands for cubic centimeters. So it's kind of just another way of writing cubic centimeters like this. So cubic centimeters, cc's, and milliliters are all the same measurement. So to complete these conversion equations, you see 1 centimeters cubed. Well, 1 centimeters cubed is the same thing as 1 cubic centimeter, right? I mean, same thing. Quite literally, you can see that in the rule up there. Now, if you have 15 milliliters, well, each milliliter is equal to a cubic centimeter. So 15 milliliters is the same thing as 15 cubic centimeters. It's the same. There's no difference. If you wanted to, you could, of course, set up like a proportion. Okay, you could set up a proportion for this if you really wanted to. I don't know why you would go through that trouble, but for example, you would use your conversion factor, 1 centimeter cubed is equal to 1 milliliter. Ooh, what happened there? Oh, I know what's going on. Hold on. So that's equal to 1 milliliter, so you could set up a fraction saying that. Oops. Give me a second so I can work this out for you. But basically, if you set that up as a fraction, then you would say, okay, if I'm told that I have 15 milliliters, that is x centimeters over 15 milliliters. So see how I have centimeters cubed on top, milliliters on the bottom for both of these? And so then I would cross multiply to get 1 centimeter cubed times 15 milliliters equals 1 milliliter times x. And so then I would get 15 equals x. Basically 15 centimeters cubed equals x is what you'd end up with, because notice 1 times 15 is 15, 1 times x is x, so it works out. So, I mean, you don't necessarily have to go through all of that on this one, right? Because this one was a little bit more simple. So take a look at this. You have 2 liters. This one's a little bit trickier. You have 2 liters equals how many cubic centimeters? I would suggest that the first thing you want to do on this is recognize that 2 liters is 2,000 milliliters. So you'd want to start with that, or in exponent form again. There we go. So if 2 liters is 2,000 milliliters, then 2,000 milliliters is how many cubic centimeters? Remember, each milliliter is equal to 1 cubic centimeter, so it's the same thing, just change the units on it. So it's 2,000 cubic centimeters because 2 liters is 2,000 milliliters. So that's what I would do. Okay. Okay, so if we're going to find the capacity of this cube in milliliters and liters, what I'm going to do is find out what it is in cubic centimeters first, because if I look at my units there, my units are centimeters. So I'm going to use the volume formula again. Remember, it's side cubed. And I'm going to say, okay, then that's equal to 6 cubed. And then I'm going to say, okay, well, 6 cubed, use my calculator, it's 216. So I have 216 cubic centimeters. And then I say, okay, now I want to change that to milliliters and liters. So remember, centimeters cubed and milliliters are the same thing. So this is still 216 milliliters. And then to change to liters, I'm going to say, okay, there are 1,000 liters, 1,000 milliliters in, in 1 liter. So I'm going to set myself up a proportion here. And I'm going to say, okay, equals 1,000 milliliters. I want to find out, I know that I have 216 milliliters, and I don't know how many liters that would be. So now that I have my units set up, and by the way, you can tell that I've got this proportion set up right because I have milliliters over liters equals milliliters over liters. That's a good thing to do. And if you acknowledge or see that you've got it that way, then you don't actually really have to worry about keeping the units through your work. Okay, so I'm going to go ahead and do my cross multiplication. So 1,000 times x equals 216 times 1. So 1,000 x equals 216. And I would need to divide both sides. Hold on one second while I stretch this out a bit. I would want to divide both sides by 1,000. I hate typing math. I will update this so that I can hopefully get writing tools soon. Okay. So now I get that x is equal to 216 divided by 1,000, which you do want to get a decimal for this. You end up with 0.216. So 216 divided by 1,000 is 0.216, and our units here was liters. Now, something to comment here is that you could have actually gotten that by just acknowledging that if you have 216 milliliters, move the decimal 3 places to the left, and that will give you the liters. So I'm going to write that for you guys. To go from milliliters to liters, move decimal 3 places left. So that's another way that you can do that, is just move the decimal 3 places to the left to go from milliliters to liters. To go the other way from liters to milliliters, you'd move 3 places to the right. Okay, so that's a little shortcut for you. Alright, so that is actually really it for this lesson. There's not much more than that here. So if you are still maybe struggling with some of these ideas, you might consider watching this recording again. Feel free to, pause and stuff like that. But hopefully this was helpful, and it's still under 15 minutes. So, and hey, send me a K-mail if this is really helping and you like that I'm embedding these videos now. Send me a K-mail and let me know that it's working for you and that you like it, so that I'll keep doing it. Okay? And just in case you forgot what those problem set problems were, here they are one more time. It's problems 11 through 29 odd on page 429. So get it done, send it to me through the Dropbox, or mail it to me at the end of the unit or at the end of the year. Alrighty? Bye.